So first we will draw prism, deviation in prism. So as we know, this is an incident ray. This is normal. This ray will bend towards normal as it is moving from rarer to denser. Again we will draw a normal. Fine. And when this ray move from denser to rarer, it will bend away from normal. Then we will make incidence angle, refracted angle R1. So this is incidence angle I1, this is R2, and this is I2. So basically incidence angle is the angle that we formed between normal and the incident ray. So I2 basically is the emergent ray. Fine. So we have to prove this delta by A plus 1 is equal to mu. Okay, so this is the angle of prism. First we are using directly this formula, the angle of deviation. What is deviation? So when we extend this incident ray and this emergent ray, the angle between these two rays is known as angle of deviation. Clear? So basically to prove this formula, we are directly using this delta is equal to I1 plus I2 minus A. Clear? So at this point, we will apply Snell's law. What is Snell's law? To apply Snell's law, directly write here the refractive index of this material, means this side, into angle is equal to refractive index of this side into the angle. So here refractive index I am considering mu1, here mu2, here again mu1. So what is the refractive index? What is the refractive index of this first phase? That is mu1 into angle in this phase, that is sine I1, is equal to refractive index of this side mu2, angle this side sine R1. Clear? So as for this case, in question this is given that we have to consider angle, we have to consider that angles are very small. So in this case we can consider, if angles are very small, we can write sine I1 is approximate equal to I1 because angles are too small. So this will be mu1 I1 is equal to mu2 R1. Clear? As we know, this is the air medium, so we can write the refractive index of air is 1. Mu2 is a refractive index of this glass prism, so I am considering mu2 is equal to mu. So here I1 is equal to mu R1. Clear? So in the same way we can write, we will apply Snell's law here. It will become mu2 sine R2 is equal to mu1 sine I1. So mu2 we already considered mu2 is the refractive index of prism, that is equal to mu sine R2. If we are considering angles are small, then we can write sine R2 is equal to R2 is equal to mu1 is the refractive index of the air, so we can write mu1 is equal to 1 because refractive index of air is 1. Sine I1 is I1. Clear? So sorry, here we have taken I2, angle is I2. Clear? So from these two equations we will get two values of I1 and I2. So directly write here the values of I1, we will get this. So delta is equal to I1 is mu R1 plus mu R2 minus A. So we will take common mu here R1. So if we have proved this equation, delta is equal to mu R1 plus mu R2 minus A. So while we are proving prism formula, we have proved that A is equal to R1 plus R2. So just take mu common. I can write R1 plus R2 A. Then I will take A common. So it will become mu minus 1 and mu is equal to 1 plus delta by A. So hence prove this equation.